Hello and welcome. My name my name is David Benson, and today I'll be talking about hijacking singletons to enable unit testing with legacy code. So, having been at the same place for 20 years, my code is part of the legacy problem. My younger self hadn't been introduced to unit tests. And if I could go back in time, in addition to telling my younger self some hot investment tips, I would then tell him, please embrace unit tests, learn about test-driven development to make your life much, much easier. I didn't appreciate unit tests until my wife went on sabbatical and I worked with a team in Amsterdam. While they were using Java, they fully embraced unit tests. So that was the cost of admission, giving out C++ for a year to program in Java. And so hence the token picture of the Kuchenhof, lovely place to go in the spring. I'm in the financial space, so I got to have some disclosures. So let me talk about the domain that I'm in, and that is distributed services or making calls to other services, to databases, and I need to be able to mock that and write unit tests against them. So you you're here because you need to make changes to legacy code to either fix bugs, add features. You own the code, you're able and willing to make changes to facilitate unit testing. You have a goal, and that's to leave the existing calling code as unchanged as possible. So Christopher DeBella yesterday talked about unit testing in the standard library in his talk yesterday. Unfortunately, I missed John's talk this morning due to some time zone things, but we're all here because testing's important, and we recognize that. So what are some attributes of legacy code? The sheer age, the regional designers or implementers are not available. Classes and methods violate the single responsibility principle, which makes it hard to test. There's large methods commingling data logic, minimal or worst case, no unit tests at all, and perhaps an outdated tool chain and language version. And while my examples today use modern C++, the concepts that I'm going to present today could be adapted to C++98 for older code bases and singletons. So just because your code has singleton doesn't necessarily mean that it's legacy. Singletons can typically make it hard to unit test as once they've been created, they can't be changed or substituted, and they're difficult to mock. So singletons. I think a lot of people picked up the Gang of Four book design patterns, found it pretty heavy. They could understand singletons, and that was the one thing they got from the book. Commonly now referred to as the anti pattern, but singletons are convenient, right? They allow for accessing functionality without having to pass dependencies. However, it's difficult to use with mocking frameworks like Google Mock. So let's take a use case logging. We all have probably cases in our code where we have some logging that we need to do. We have a library to do it. You might want to have some timestamps, thread ID, locking to make sure that different threads don't overwrite each other, log levels and thresholds, and some formatting. Simple case, you log to a file, more advanced case, network. And you might have some limits on the file size, rollovers. What do you do? Do you compress them? All kinds of things. You might get fancy and do some duplicate suppression. But I'm going to use the use case of logging to show some ways that we work with singletons. And the logger that I'm going to show you has none of its nice attributes. Its biggest redeeming feature is that it fits on one slot. So with that, should be a logger with a legacy singleton. We have code somewhere, and I have chosen to simplify the code. There's no namespaces of any form. This would definitely be a namespace. And so we call our somewhere deep in our call stack, we need to log something. It calls this free function, or perhaps used directly some form of getting an instance. And we get that instance pointer, we dereference it to call the debug method. And so what does this look like? Okay. So this is kind of a legacy singleton. We have a method, perhaps called instance, that is static, so we can call it anywhere, and it returns a pointer to a log. And the first thing we need to do is make sure we don't have any race conditions. We only want to create one singleton, so we check it. We'll set, we have to hit the lock, and then we check the singleton one more time to make sure that it wasn't already created. Go ahead and create that new logger object, and now we have actually created our singleton. Just one thing to note, very typical. We make our structure be private, and that way, or perhaps an old code, you would mark it as deleted. Um, Or sorry, not delete, but you put it here as private. And that way, there can only be one way to create it, and that's through our instance. And so we have this singleton. There's only one copy of it, this logger object, but it has a lot of disadvantages. We can't control the lifetime, and we can't replace it and do mocking. So how can we do better? In C++11, we got the Meyer singleton, or referred to as a function static. And this is, we're going to take advantage of this and do things a little simpler. Instead of returning a pointer, which has questions about could it possibly be null, I'm going to return a reference for my static function. And the way we can do this is very easy. You just have a static inside inside a function or method. And this is going to create and initialize this one instance of the logger object, and we will easily return it. And through the magic of the compiler and the language design, it takes care of the startup condition, ensuring that there's only one object, that there's no race conditions, nice and clean. We can understand it. And now we have a starting point to be able to um, make enhancements to this to start getting some capabilities that we want to have. Again, lifetime replacements and ability to mock it. So can we do better? Let's extend this. So just here we have the usage, um, the how we get the instance obfuscate changes. We do. Okay, so let's talk about another case. Is that we want to be able to control the lifetime, and in this first attempt, it's manually controlled. So instead of giving back to working pointers, I'm choosing to give out a unique pointer, and I'm giving out a reference to unique pointer, which I know is a slightly odd signature, but I have reasons for it. So here, I take advantage of that function static. I have a unique pointer. I call make unique my logger object, and I get my one static. Now I have this new method that could have been in the function. I chose to make it a free function. It allows me to override my logger by taking advantage of the unique pointer, and I can swap it out. So I can say instant swap with this new logger. So what can I do? Um, I might write a very simple unit test. And in case of logger with a so it's trivial, it's not that interesting. But I would want to perhaps have some, if I had a more complicated logger, use various tests. And I can't do that until the object has gone out of scope. And so to do that, because in this case I might be outputting some content that's buffered, I can't actually open up that log file like on my Windows. I might have that exclusive lock, and I want to make sure that all that content has been written, so I can force my logger instance to go out of scope by calling my set logger with a null pointer. And that's simply going to go back and swap out the logger that I had. And that's through the magic of the unique pointers destructor. It's going to take care of cleaning up my object and closing any open file handles. And now I can write a unit. So it's better. We can control the lifetime, but it's a little cumbersome. Can we do better? So let's explore an attempt to do things with a weak pointer. Um, And here we start out again with our function statics. We have a mutex, we have a weak pointer. And the first thing we want to check after getting our lock is is the weak pointer pointing to a valid object? And we can check that with the expired. And if it has expired, was never seeded to begin with, we're going to create a new logger as a shared logger, and we can give that back. Otherwise, we assume that our weak pointer does point to an actual object, and we call lock, which escalates the weak pointer into a shared pointer. But what has this gotten us? Okay, so we have some ability to. So before, this is just saying that if we have a logger, we have one logger, it's going to assert that they're equal. Okay, that's not very interesting. That was what we had in all the previous instances of our singletons. But now with a little bit of work, I get two things. One, I can call the instance and I have a scope. So as I go out of the scope, it's gonna go out of scope. If this is the one and only copy of the logger, then it'll get destroyed. And I can do my test to see that it's been cleaned up. Or more likely, if I was writing a series of unit tests, I can have one do one set of actions. Maybe there's some constructor parameters, and then I have another one, and that gets different set of attributes. But this has some serious disadvantages. So we can control the lifetime, but we can't guarantee that someone else hasn't already created an instance. And we can't, if one's already been created, and if our simple object had structure parameters that we access to perhaps the instance, we can't change them. So we can't guarantee, we don't have a way of getting rid of the one that already exists because we don't know who has references to it. But it does have this nice property that it allows us to start transitioning our code base from this pure singleton access to perhaps I want to be able to actually get access to this, hold on to it, and pass it through my code and start evolving towards a design where I'm passing an object or an interface down through my hierarchy. Okay. Can we do better? Let's hope so, because we can't mock this. Okay. So a mockable singleton with inherit. What is this going to get us? Um, so here we have back to our unique pointer signature. And instead of giving out the actual logger, I'm giving out an interface. And I'm making an intentional decision not to have a default implementation. If the default object has a network or database dependencies, we don't want those to be accessed, particularly in our unit tests. We don't want to have our CI system requiring access to the database or having these external dependencies. And we would need to code defensively to handle potential null pointer where it's being used and accessed. So that does require that somewhere once in your code, you're going to call set logger with a new logger. And in our case, we would probably bury that in some code that already handles our service startup so that most developers wouldn't have to see additional code. But what does it get us? It gets the ability to mock this code. And I realize this is a trivial example. We're calling our debug method, which is void, but get the idea. We can make a mock object that through gmock that's going to define the methods through this interface. I'm not showing that. And you say expect call, and here we have a slight different usage. Normally you mock on a value based object by making unique. I have a pointer, so in order to make the expect call it, that's an actual object. So I'm going to dereference it. And debug is my call. That little underscore there says wildcard for any parameters. And then in order to allow the actual mocking, I call set logger. I move in my unique pointer, my mock. And now when it actually calls that debug statement, it's going to use my mock. Great. So we've achieved our goal of having taking that singleton, modifying it so that we can change it with controlled lifetime, not as elegantly as we like, and be able to mock it. And unfortunately, as much as I wanted to try have a nice example with the weak pointer that would allow me to have all these nice attributes, I can't really get it to work elegantly. So this is kind of the best I have. So let's talk about another use case. Database access. Um, Probably going to do various things like connection pooling because often that database access are relatively slow and expensive to open. You might want to have some for bound connections, not overwhelm your database. You might have a logical to physical mapping of servers, databases, and stored procedures to allow you to control where those are and adjust resources independently of your code. Perhaps protection from SQL injection attacks. We don't want to drop little bottom tables. Um, might do some caching. We put it in our SQL layer, so it's harder to abuse your database, and perhaps some vendor agnostic replication. In our million lines of code, we have over 900 database calls. Yes, we love our database. So our given goal was not change the interface of the calling sites because I just can't possibly change 900 places and pass down through an interface in order to get it to work. So how can I work on this? Obviously, if I was starting from scratch, I might have the method which get prices, hiding any useful parameters I might want, and you would pass in this database pool object interface that can be used, that can one be mocked and it can get a connection out of it. And so, you do have to pass this down through your call stack, which means it's hard to adapt this to legacy code. In Java and C Sharp, we have dependency injection frameworks, which can handle dynamic binding to avoid needing to pass through call stack. However, this introduces the level runtime risk of failed bindings. So, all right. So how will we write this? Uh, having using Gmock to be able to write a test. I had this connection. I made a connection mock. I have an expect on this connection, the execute method where I'm not specifying parameters. And when I say it's going to return some data, and just for purposes of simplicity, I'm returning JSON legacy code. Probably, well, this is our new version. And then I have for the database pool object, which is a little more complicated. It's in return a pointer of some sort to a connection. You have to pass in return and give it the address of our connection object. And that way, when we actually call get prices, we pass in our mock pool, which will connect that to the mock connection and return the data we want. So therefore, you achieve our goal of being able to mock our code. Right. But all that comes with a certain set of requirements. Gmock requires inheritance. And yes, if you read the Gmock documentation, they talk about switching. You can use templates, but that's a pretty ugly solution. Um, it it requires a heavy change to the existing implementation code that was nicely hidden away behind a header and separate compilation units. Now it's all exposed in templates and got potential slower build times. And you might be saying, well, how bad is it that I have inheritance? I'll leave it up to you to decide. It's not always evil, and particularly how the network call were being made. Obviously, the runtime penalty is quite small. But I had another problem with my code in that not only did my database code was it didn't use singletons, the authors thought that one singleton was so good. Why not have five singletons that all kind of cooperate and work together? And so it just became pretty tricky in our case to change that implementation. So can I unit test legacy code without inheritance? So here's a legacy code. The interface isn't quite as nice as it was before. We have some kind of response object that we get back as an output reference parameter when we call execute. So what does this actually look like? I don't see a singleton, right? So our query execute method, it accesses a singleton under the covers, gets this connection, and then calls it. So how can we work with this and kind of inject some behavior and override? We can take advantage of a standard function that we define. There's some object that some method is going to return a Boolean. You pass in query identifier. In this case, we have to use integers as part of that logical to physical separation that I talked about, and a reference to the response object. And so inside of our execute method, we're basically going to write a little code that says, hey, if you passed in this test handler, go ahead and execute it and pass the parameters and do the response. And yes, to make this nicer, we would put perhaps an if-def debug around this code so that you couldn't possibly invoke it in your production systems and hide away this extra object. But we have this way of kind of changing behavior. But now, how do we link this together? Because now every call to the connection would require some form of a handler. And here we have, going back to our connection pool, we have some instance using our minor singleton, and we would have a set method. And this allows us to set the behavior. And then here, this is actually not a very good example of our connection pool because it only has one connection. We would need to maintain everyone SOFI, and yes, it should return by reference. And what I don't show here correctly is that we would have a default implementation of a handler, or rather, a null handler is going to be empty. So when we call it, it's not going to, in the base case, it's not going to attempt to call our handler. It'll call back to the regular code. So with this, we have our own mock objects. To, by needing to work without inheritance, it's difficult to work with Gmocks. Kind of have to roll our own a little bit. So in this mock response object, it sets a handler by accessing our connection pool. And it very simply takes in the query ID. We have a little unordered map, so we can have multiple queries, different types of queries, and turn different responses. And if we find something, we take this response and put it back and return the results. And this is a simplified implementation. I'll talk about some of its other functionality later. And so here we have a slightly different variant on our unit test. In our case, we wrote it so that You ask for mock response object. You can say mock add for given query. And here's the data I want to return. And there's some optional inputs you could define as well. So, the one thing we did like about this, yes, I know when you roll your own code, you say how great it is. And I guess I have to say that too. It's simpler. It's easy for our developers to create these and work with them. So none of this is earth shattering. You can do all these things in our own homegrown mock. You can do them all with some amount of effort with Gmock, but we can mock multiple calls, each with different responses. Okay, my simplified implementation has that. And what I didn't show for simplification is we allow you to have different inputs, each with different responses. We make it easier than I think Gmod because by default, you only have to specify the input parameters that you know are different, and then it'll match the first one, and then it'll return those. And we allow you to update an existing response so that you can have different responses for first and subsequent calls. Perhaps one of your calls is transactional in nature. You don't want to be able to read. There's no transactions. You insert one. Now you read again, get back those transactions. And then once you define a mock, all subsequent calls are mocked. And so this allows to make sure that if you set one in one unit test, you don't have other unit tests that silently are actually accessing the backend system. So let me come back to my pricing example, which was intentionally simplified. Um, it wasn't very useful. And let's make it a little more useful in that to get prices, I'm going to need some form of a symbol, a start time, and end time. But to do that, it turns out that I need to get this symbol object, and this symbol object is actually going to do some simple translation. It turns out that if you're not in the finance world, there are hundreds of different types of ways to represent uh, stock exchange tickers. And so here, I then have to fill in for this translation. In this case, from Rick to some internal identifier. So that's one more a piece of data I have to mock. And then we say, oh, actually, I want to specify some times for today. When does the exchange open and close? That makes another call to get some exchange hours. Perhaps it even needs to know about holidays and stuff like that. So anyway, we start having this case where just to write what seemed like a simple case that I just want to write a unit test that gets prices. I suddenly perhaps having to specify more and more things. And so that's the thing they have a scope creep, but it does naturally lead to how do you get test data? So once you have this nice capability of mocking calls, the next question is how can you get valid responses? Because just putting in arbitrary text into a unit test is likely not to be very useful. Yes, fusing is very good, but if you're trying to test specific cases or match one that you particular bug on, you want some live data. So what we did is we have an interface for applications, which we enabled a way to enable tracing. So we can make a request and say, turn on tracing for 5 minutes, after which the tracing will get turned off. You can also have it enabled via command line switch to get all that data, which is loaded at application startup time. And this is intended for collecting data locally, so I didn't make it particularly sophisticated. Doesn't have a lot of buffering. It just writes one file for each of these requests. It has an identifier identifying the request. Inside that file, I have the inputs to what the database call. I have the responses. So we can take this data and make some useful tests for our data for application. So let's do one more use case. Talk about API calls. So this, like I said, this is legacy code. We long time ago wrote our own um, network transport protocol that took care of a couple things for us. Um, and so it has to do with its own service discovery. This was written before we had ubiquitous load balancers. It does some connection pooling to reuse sockets, serialization, deserialization, and we have lots of these calls. So we have lots of places where one application called another application to get data and to do various actions. So here's some existing code we want to test. We have this connection, this client object that we does two-phase initialization, telling me kind of how old and how to style it is. And it says, hey, I need to access this pool, do some simple cross-reference. And then we access this client object, make an execute, pass in some requests and some response, and gives you back various pieces of information. And this client object is pretty heavy. And so it has background thread that does checking the universe of servers, making sure they're up and they're healthy. And so you don't want to just create these client objects all over the place on the stack. We want to reuse them. And so we always had this problem like how to make sure developers are educated to know that they should reuse these. So how can we get access to this? This client object, because the way it was constructed, it creates a background thread. So it wasn't easy to kind of get in there and change the solution. Add a singleton. Wait a minute. Didn't you just start this talk by saying how bad singletons are? I did, but they're useful. And they give us an access point for getting in and making changes. In this case, we're going to return a reference to a interface, mock behavior. And what I'm choosing to do here is changing the calls, the construction of my object versus the call site. Pretty common that we'll create the client once in a particular area and then reuse that client for different types of calls with different sets of inputs and outputs. This also gives us the nice thing that we maintain the kind of connection once and we can give it out if we ask for another place in the code. So if you forget that the client is heavyweight, we kind of solve that problem by having a pool. Yes, there's a small cost of a lock to get and look up that pool, but it's pretty small. Or in the case you look it up once and you have this reference to it, you don't have to worry about it. All right, so what does this look like? We have a get client method, pass in some pool name, kind of say, hey, pool, give me a connection, take advantage of our Meyer singleton approach with giving out a unique pointer and having the ability to swap it so that we can write some unit tests. And what does it look like to write some unit tests? We have our execute method on our client. This lovely syntax that Gmod gives us, which says, if you want to return an output reference, you say set referee and give it the index of the value. So I'm going to return this data object. This will return true. And here's this data object that I created so that I can pass it into the output response from the call. And then here's kind of getting access for when I ask for the pool. In this case, I just didn't match the input parameters. And then again, my trick of calling set pool to pass in that unique pointer so that I wired these things together and I have access. So now I add this unit test. I will get mock data when I make this call. All right. Now for the hard part, adoption, right? Creating a unit testing mechanism for legacy code, get it to work, iterate through a couple of times, finding those thorny parts in your code, writing, give some examples of how it gets used, documentation, presenting to your peers on how it works. That's pretty bound. The open-ended part is convincing your peers to use it and going through existing code and going from 0% coverage to a high number that satisfies your testing bar. So how do we get there? Starting with senior leadership. Hopefully your CTO is on board with the whole DevOps, shift left. They're familiar with the DevOps report. If they're not familiar with shift left and kind of the value of this, perhaps it's time to polish up your CV and start looking for other opportunities. So we're really trying to move testing, as we all know, is why we're here, is move it from something that we do after we build it as part of kind of our release candidates and kind of before we get to deploying and moving as part of your development process and making sure that developers are testing their own code. As you move from the CTO kind of on down to the organization, the product owner is one you're going to really have to work with. And there's this natural tension between features and schedule and quality. And a lot of product owners just, they love to get that new feature for the client. They want it yesterday. And they're like, no, just whatever you got to do to make it work and get it right. But the problem is if we don't start building in quality at the time of building it, it makes for a very poor foundation. It's difficult to add additional features. It's difficult to refactor. So we really need to change the definition of done to include unit testing, and it's going to take a effort. And you're gonna, and hopefully this your CTO can help back you up and drive your organization to kind of understand. Let's talk about the developers and how we can interface with them and when we can kind of push this change in behavior. Yes, we've done our presentations internally to our teams and really gotten them to try to believe in this. And what's interesting is the younger developers, you probably learn test-driven development in college or university. They're quicker to embrace it, but kind of people have been around for a while and gotten away into a habit of not writing unit tests. They're the hard ones to convince. And so that's going to take time. So I start when I review code by actually reviewing the test first. Sure as my API is testable and usable. And early on, after you've kind of demoed this and shown it off, I just you're Mr. Nice Guy, right? It's like, look, I see some code. Looks like you have quite a bit of logic here. You could definitely write some unit tests here because you have network dependencies that we can now mock. You link to the unit test documentation and some nice examples. And as time goes on, you start becoming more assertive. And when there's missing tests, they become tasks and which block merging. So we can do that in our tool Bitbucket. And then as you move forward, start doing enforcements. We're using SonarQube to enforce that new code has some amount of code percentage covered. And we're starting out with a lower bar and working to move it higher. And one of the big areas of pushback is that we see developers, they write the code and like, oh, and you say, I need that test. Like, well, I'll do that in new ticket 1, 2, 3, 4. I'm like, no, you know that I know that ticket in a future ticket is never going to get worked on. It's going to be relegated to the backlog and it's just never going to get worked on. So I would love to show you some beautiful metrics of code coverage and how that has increased steadily over the last couple of years with my team. But unfortunately, I don't have those metrics in a way I can show them to you. Um, and I have some areas where, old applications which are on life support and haven't been touched in a while, other than to kind of just rebuild them, deploy them, they sadly have no unit test covered. But the teams that are working in their applications every week and they're constantly making changes, I've seen some really good adoption. And we're starting to see, okay, all the new code is covered when they go into a new area to make a change. They're adding the unit tests. And it really is kind of a clean as you go approach is what we've taken. Um, no one, no business side of the house is going to support stopping new feature development just so you can go in and add, get to 80% unit test coverage on some piece of code just because you think that's what you need to have. So it's slow. And there's really kind of this long tail of adoption. But what we've seen is once you give them the capability, things get better and you do have to push. And so in our case, as one of our technical architects, I review a lot of code and review code across different teams. It's a little bit easier for us. We use a mono repo approach. So I only have to go one place to see all the pull requests. Otherwise, you're going to have to be chopping in to look at a lot of different teams and what they're doing. So I just want to leave you with a key point that we have a mockable singleton, and this is our something you can use, and hopefully it allows you to take a start whittling down on that legacy code that doesn't have unit tests and build quality into your application.
Thank you.